In this chapter, we're going to look at topics related to measurement. In this lesson, we're going to look at the surface area of prisms. All right, hi everybody. So in this lesson, we're going to take a look at the surface area of prisms. Okay, so first of all, just a little bit of an introduction to that. First of all, we're going to talk about three-dimensional figures, okay, because that's really what a prism is. In fact, any object that exists has three dimensions to it, length, width, and height. So 3D figures are made up of polygons, are called polyhedrons. Okay, it's just a fancy word if you've got something that's made up of a bunch of polygons here. So like a classic one would be like a cube, right? Cube is a polyhedron made up of a bunch of squares. So you get the idea. Now, there are two classes of polyhedrons that we're going to be concerned about in this particular course, and that's going to be prisms and pyramids. Okay. Now, for this lesson in particular, we're going to be looking at specifically prisms, and then in another lesson, we'll take a look at pyramids. So, and there are also two measurements that we're going to be primarily concerned with here in this course. Surface area, which is the amount of two-dimensional space, okay, that all the faces of the object take up, and volume, okay, so which is the amount of three-dimensional space that it takes up. But again, we're only going to be focused on the surface area of prisms in this particular lesson here. Now, okay, so now to understand prisms here, we just got to make sure that you know what it is specifically that we're talking about here. So we want to get the surface area of the prisms. We have to understand what the prisms themselves are. So first of all, a prism always has two bases, okay, and they're the same polygon. So you can have like a square at the bottom, and actually I shouldn't even use the word bottom here because that kind of communicates something that's not true. You can have, like, let's say squares at both ends, and then we just connect the lines, the points there with straight lines. So for example, here's a square, we've got another square over here, and then we connect those lines together, okay? And so there's your prism. So it's going to have the same shape on both ends, and then we simply connect the vertices with these straight lines to create a bunch of rectangles around the sides there, okay? So yeah, there's that other bit right there. The lateral faces are going to be rectangles. And so the number of lateral faces always depends on the number of sides in the polygon base. And then here's this little point here to be made. The base of the prism is not dependent on the orientation. Okay, so base doesn't mean bottom or top or whatever. Even though, for example, this one is lying on one of its lateral faces here, these are the two bases. Okay, so just something to consider when you're thinking about that, because it's often very easy to get confused by that, because we use the word bottom slightly different when we're just kind of talking about things. The base of the prism is dependent on the shapes of the polygons in the polyhedra and how many of them there are in the figure. The net. Okay, so that's that two-dimensional pattern that we can kind of open up these prisms into. Okay, it's a 2D pattern that can be folded to make the 3D prism. Now that's usually the net is how you want to think about these objects when you're trying to find the surface area. Okay, because it's a lot clearer what you need to do when you look at the net of a prism or a pyramid for that matter. We'll take a look at some examples here in just a moment. And so then to calculate the surface area, we calculate the area of the bases and then the total area of the lateral faces, so all of the rectangles, okay? So the surface area here is going to be the area of the bases and then plus the area of the lateral faces here. Now in this case here, for prisms, these are all going to be rectangles, but the bases here could be any kind of different polygon that you can think of. So we're going to have to work probably a little bit harder to get that area than it will be to get the area of the rectangular faces. Okay, so now we're going to start by taking a look at a scalene triangular prism. So what that means is the bases of our prism here are going to be scalene triangles. So none of the sides are the same length here, which means we're going to have, when we look at our lateral faces, we're going to have three unique rectangles. Okay, so we're going to have to find the area of each one of those independently. So here we go. Here's our surface area formula, and you'll notice right here 2 times the area of a triangle. Well, that's because that's our base. And so we've got our length times width divided by 2. There's our triangle. And then we multiply by 2 because there's 2 of them. Now, when you take a look at our triangular base here, it's 8 by 15 and then 17 here is the other side. It turns out that's not just a scalene triangle, it's a right triangle here. So this is going to be our height, this will be the base here, the 8, when we pull that up here. So it's easier to see right here. You can put the little right angle right there. the base is going to be 8 and the height is going to be 15. So our surface area will be 2 times 15 times 8 divided by 2. And now I'm just going to work through all of the different rectangles here. So let's start with this one. Now remember, there's this height of 33. So for example, let's take a look at this one right here. It's going to have a length of 33 and a width of 17. This next one is going to have a length of 33 and a width of 15. And then this last one over here is going to have a length of 33 and a width of 8. And so what I'm going to do here is I go to my calculator and just plug this all in. So 2 times 15 times 8 divide by 2 plus 33 times, whoops, not 27, 17, plus 33 times 15 plus 33 times 8. And I get a surface area of 1,440. And we got to just think here, what are the units? There's no units, so I'm just going to put units squared there. Now let's take a look at an isosceles triangular prism. So in this case, the two bases that we're going to be looking at here will be isosceles triangles, which means 2 of the sides are going to be the same. Now, because that's true, that means we're going to have 2 rectangles that are identical, so we can take advantage of that, and then we'll get one unique rectangle. So again, 2 times, then length times width divided by 2. That's the area of the triangular bases. And then 2 times length times width. This is because 2 of the rectangles are going to be the same, so we can take advantage of that by multiplying by 2, and then we've got that extra rectangle right there. Now, first of all, when we open this thing up, this is what their net is going to look like. Notice we've got the 2 isosceles triangles here. So I'm going to get the area of those triangles, I got to drop an altitude here. And I'm going to call the height of this thing h here. Now, when you drop an altitude to an isosceles triangle, it's going to cut that base in half. So this is going to be 3.5. So what I want is I want the height of that triangle. So my height, I'm going to use the Pythagorean theorem here, by the way. H squared, the height squared, plus 3.5 squared should equal 5 squared. So I'm just going to go to my calculator and plug those in. So 3.5 squared. So h squared plus, this is going to be 12.25 squared, not squared, just 12.25 is equal to 25. So 25 minus 12.25, okay, is going to be 12.75. So my h, my height, is going to be approximately, now I'm going to take the square root of that answer that I just got, and I'm going to get, and I'll show you over here, I'm going to get approximately 3.6. Now I'm going to leave that number in my calculator so I'm using the entire decimal, and that just minimizes any kind of errors that I might get as a result of rounding here. So now I know that the height of that triangle is going to be 3.6 here. Good. So my surface area is going to be 2 times, for the 2 triangles, the length times the width, the base times the height. So that's going to be 3.6, what I just calculated here, times 7 divided by 2, plus, now I've got 2 triangles that each have a width of 5 and a length of 12. So it's going to be 2 times 12 times 5, plus, and I've got a single triangle here that's going to be 7 by 12, or 12 by 7, length times width. And now I simply go to my calculator. Whoops. Sorry, I typed in something wrong there. I go to my calculator, and I will go 2 times that answer, what I just did, multiplied by 7 divided by 2. And so those 2's are going to cancel. But anyway, plus 2 times 12 times 5 plus 12 times 7. Okay, and so we get roughly 229.0 when I round to the nearest tenth. And in this case, once again, I'm looking for units. There's no units. This will just be units squared. Now, the last kind of triangular prism we're going to look at is the equilateral triangular prism. In this case right here, again, the bases are going to be these equilateral triangles. I can use the same method that I used just a moment ago to find the area that I'm going to drop an altitude. There's my height. And I know that that height is going to cut that base in half, so this will be 3. So again, I can use the Pythagorean theorem to figure out what the height is. I know that h squared plus my 3 squared will equal the hypotenuse squared, 6 squared. So h squared plus 9 will equal 36. So h squared is going to be 27. And so when I take the square root of 27, I get roughly 5.2. Okay, so there's my answer right there. I had to round that a little bit, but that's okay. 5.2. Again, I'm going to use the decimal that's on the calculator, not the 5.2. Now in this case, because it's an equilateral triangle, all of the rectangles that form the lateral faces, they're going to be identical because all of the sides are identical. So my surface area here is going to be 2 times the length, okay, times the base, which is going to be 6 here, all over 2. There's my triangles, okay, the two triangles, the two bases here, plus 3 times, and in this case the height is going to be, or the length is going to be 9, and the width is going to be 6. And so now I go to my calculator. 2 times, well, that answer that I just worked on, 2 times that, times 6, divided by 2, plus 3 times 9 times 6. And I get approximately 193.2. Again, I'm looking for my units. I don't see there, so units squared is what I would write. Okay, so now for this particular shape here, we're going to look at a square prism instead of a triangular prism here. Now, again, we've got two bases here, and their bases are both going to be squares, and so that's going to give us 4 identical rectangular sides here. And if we open this up, and actually this is not a good, well, actually I shouldn't say that. I see what's going on here. So here's my base right here. There's one base, and then the other side is also base. So there's my square there. So here are my square bases here, and then I've got these little rectangles here. So our formula here for the surface area is going to be 2 times s squared. So 2 times 11 squared. Okay, in this case, because the sides of the squares here are 11. That's going to be the same here and here. Plus, now each one of these other rectangles here, because it's a square prism, each of those is going to be the same. So there'll be 4, and they're each going to be 11 by 6. So now we pull out the calculator here. 2 times 11 squared, okay, plus 4 times 11 multiplied by 6. Oops, and you just barely see that, 506. So our surface area will be 506 units squared. So there's a square prism. Now, we follow that with a rectangular prism, where the base, okay, is going to be a rectangle here. Now, that means, because the rectangle's got 2 equal sides here, 2 pairs of equal sides, we're going to have 2 pairs of equal rectangles going around. And you can see that here. This rectangle will be the same, and then these two will also be the same. Okay, so now our surface area, this one's quite easy. So our surface area is going to be 2 times, let's say length times width, so 19 times 7, plus 2 times, this one here is going to be 12 times 7, plus 2 times, over here this is going to be 19 times 12. Basically, every side gets paired up with every other side, and then we have two examples of each of those. So this is going to give us 2 times 19 times 7, plus 2 times 12 times 7, plus 2 times 19 times 12. Okay, just make sure I got all that in there right. And we get 890 units squared. Now, we've been working with some pretty standard shapes here as the bases. We've been working with triangles, and we've been working with rectangles and squares. So now we're going to move on to doing working with prisms here, where we're not working with your standard sorts of shapes here. Okay, so we're just going to look at one example, and then we're going to come back and talk about this again in just a moment here. But just to show you an example where that's a little bit different here. If you've got pentagonal, hexagonal, or blah blah blah, whatever regular polygons at the bottom here, what we're going to do is we're going to break these things up into triangles. Okay, we're going to take a look at the bases here. Now, all of our sides are still going to be rectangles. Okay, and if it's a regular polygon that we're using as a base, then they're all going to be exactly the same. So now here, for my bases, what I need to do here is figure out the area of each one of these regular polygons. Now,
that's going to be relatively easy to do as long as we're given the distance from the center straight down to one of the sides. And the reason why we want that is because what I'll end up doing here is drawing out triangles. Okay, so from the center I'm going to draw connections to every vertex, and that's going to create, in this case, 5 different triangles. So my surface area is going to be, like they have written here, there's going to be 2 bases. This is 2 for the 2 bases right here. Then I'm going to do length, and the length here is going to be 6, times the height is 4.1, so it's key that I'm looking at this height right here, 4.1 for that triangle, divided by 2. So this little bit right here is going to be the area of this triangle. I'm going to multiply that by 5 because there's going to be 5 going all around here, and then multiply by that 2 for the 2 bases here. Okay, that's how we're going to do this. Now we're going to come back and look at another couple of examples related to that, just to make sure that that makes sense. And now, each one of these, and there's going to be 5 of these, the length is going to be, let's say, 6, and the width here is going to be 7, or however you want to interpret that, length, width, whatever. So now we just plug this into our calculator. So 2 times 6 times 4.1 divided by 2 times 5 plus 5 times 6 times 7. And we get 333 units squared. Okay, so there we go. So that's kind of how you would handle one of these things with, like it's a regular polygon as the base, but it's not a shape that we're immediately comfortable with. So we break it down into triangles. Now a couple more here. A cube. Now it's almost going to look like we're simplifying things, we're backing things up a little bit, but there's a shortcut for the cube that we want to make sure that everybody gets here. With a cube, it's still like a square prism here, but the height is the same as the length and the width here. So all of the sides are going to be exactly the same. And when you consider it, I've got 2 bases and then 4 lateral sides. That means there's 6 sides that are identical to each other. So in this case here, my surface area is going to be 6, and then it'll be 14 times 14, length times width here. So that's how I would figure that out. That's my little shortcut there. So 6 times 14 times 14, you get 1,176 units squared. Now, one more, and this shape here is not uncommon. You see cylinders all over the place here, but it is a little bit unique in this little group here. So the cylinder has got 2 circular bases, and so the areas of those circles are going to be pretty easy. It's going to be pi r squared. Now, the thing is, it only has 1 lateral face. Okay? Or you might even think of it like an infinite small, itty-bitty little lateral faces here, but it's easier to think of it as just 1 lateral face here. In order to get that, what you do is you give it a cut. You just kind of slice it down and then unfold it, and you'll see you get this rectangle. So the width of the rectangle here is going to be 7, which will be the same as the height of the cylinder. But now what's the length? Well, the length, you got to think about it here. This thing gets wrapped around the circular base here, so the length of the rectangle should be equal to the perimeter or the circumference of the circle, and that's 2 pi r. So that's our formula here. So in this particular case here, this is going to be 2 for the 2 circular bases here. Pi times my radius is 5, so 5 squared, plus 2 pi times 5, that's again the radius of the base, and then multiply, and that's right there, that's going to be the circumference, and then multiplied by 7, the height. Now, because of the pi's in there, I'm going to end up approximating this, but anyway, 2 times pi times 5 squared plus 2 times pi times 5 times 7. And this is going to be approximately 370, let's say 7 units squared, rounded to the nearest whole. Oops, sorry, you can't see that little 2 there. Rounded to the nearest whole there. Okay? Good. Okay, now before we finish up here, I just want to go back and revisit this idea of finding the area of a regular polygon. So you can, like it says here, you can find the area of the regular polygons beyond 4 sides by treating them as composite figures, okay, which means we're putting together other figures, other simpler figures, and then dividing them up, or I should say, dividing them up into triangles with the center of the polygon being where all of those triangles kind of meet there. And then you find the area of one of these triangles and multiply it as you go around. Okay? So if you've got 5 sides, a pentagon here, a regular pentagon, 5 sides, I'm going to be able to create 5 triangles out of that. If it's a hexagon, I can create 6 triangles, and so on and so forth. So let's just take a quick look at a couple of examples here. So the surface area here is going to be, well, this is a hexagon. Okay? So I'm going to get 6 triangles here. Okay, 6 triangles just by connecting that center to each vertex. I know that the base of each one of these triangles here is going to be 10. And I know that the altitude of each one is going to be 8.7. Now remember, a triangle is base times height divided by 2. So the overall area of this shape is going to be 6 of these triangles. Base is 10, because all of them are going to be 10. And the height here is given as 8.7, and they're all going to be the same here. So 6 times 10 times 8.7 divided by 2. And I get 261 units squared. Over here, this is kind of an awkward looking shape here. Let's just count how many sides we got. 1, 2, 3, 4, 5, 6, 7. Okay, so 7 sides. So I'm going to have 7 of these triangles. And again, I just connect each vertex to the center of the circle to see those 7 triangles. Each triangle is going to have a base of 13.5 and an altitude of 14. Every one is going to have the same one. And then remember, the formula for the triangle here is going to be base times height divided by 2 and then multiplied by 7. So 7 multiplied by 13.5 times 14 divided by 2, and I get 661.5 units squared. Okay? And so that's how you figure out the areas of these regular polygons that we might use for the base of a prism or a pyramid later on.